Okay, so in our next part of trigonometry, we're going to be focused on angles instead of triangles. And when we do that, we have to all draw the angles beginning in the same place. So we have to learn about angles in standard position. In angles in standard position, you always put the vertex at the origin, so right at 0, 0. And then draw the beginning of the angle along the positive side of the x-axis at 0 degrees. A positive amount of degrees, we're going to rotate around the axis clockwise. So straight up would be 90 degrees. Over here to the side would be 180. Down here at the bottom would be 270. And completing the circle would be 360 degrees, because we all know there's 360 degrees in a circle. If the degree measurement is negative, then that'll be the opposite. Rotating negatively, we would rotate clockwise, so this would be negative 90 degrees down here, negative 180 over here, negative 270 up here, and negative 360 over here. All right, so let's try to draw a few. It's pretty easy, and you don't have to show much work. You need to make a quick XY axis, and you need to show that it starts at 0 and along the positive x-axis. And then we just estimate where would 240 degrees go. Each quadrant here, there's 90 straight up, 180 over here to the side, 270 down here at the bottom, and so 240 is bigger than 180 but smaller than 270, so we're going to draw the angle finishing in between those two. A little bit closer to the 270, and that's it. That's our angle in standard position. We rotated 240 degrees counterclockwise because it was positive. 70 degrees. Again, we draw a quick XY axis. Start at 0, 0 in the positive x-axis, and then estimate where 70 degrees would lie. Straight up is 90 degrees. We start at 0, of course, so we don't make it very far in this one. We're going to stop before we get to the 90 even. It's an estimation of what 70 degrees would look like. All right, what about negative 50? We start at 0. 0 does not change. If it's negative, though, we're going to count clockwise. So negative 90 would be down here at the bottom. So negative 50 does not make it to negative 90. It makes it a little over halfway. So in the clockwise direction, there's negative 50. Okay. Now, dealing with positive rotation and negative rotation makes us realize that there's more than one way to draw an angle that looks the same. And when that happens, we're dealing with something called coterminal angles. It's when angles are in standard position, but their terminal sides coincide, which is a fancy way of saying they end up in the same place. They end in the same place. Okay, that can happen when one is positive and one is negative. One rotates clockwise, one rotates counterclockwise, and they end up in the same spot. Or that can happen when you add or subtract 360 degrees, or several 360 degrees. So the angle is making laps around the circle before it stops. So my advice for drawing coterminal angles is to always find the smallest positive coterminal angle and then draw that. Okay? So 485, that's bigger than one lap around the circle. A circle, remember, 360 degrees. So if I subtract a 360 degrees, I realize I have 125 degrees left over. So a 485 degree angle would look exactly the same as a 125 degree angle. So if I just graph the 125, then I will have drawn the picture for 485 as well. So let's see, 90's right here, 180's right here. So 125, I think it's a little closer to the 90. So 125 would just start here and go to here. This went all the way around and stops there. That's how I got to be 485 degrees. But a 485 degree angle is said to be coterminal with a 125 degree angle because they end in the same place. All right, negative 75 degrees. The smallest positive coterminal angle, I would need to add a lap around the circle to get it to be positive. So I would add 360 degrees, and that puts me at 285, I believe. Okay, so if I can draw a 285 degree angle, it will look the same as a negative 75 degree angle. So since I'm trying to draw something that's positive, I can put 90, 180, 270, 360 around my circle. And 285 is just a little bit bigger than 270, so we'll put it here. So 285 would go this way, or of course the original negative 75 would have gone that way, and they end up in the same place. Okay, last one, and I hardly have space for it over here, 800. If I take away a circle, then I still have 440 degrees. Oh, so this one needs another circle taken away, another lap, which leaves me with 80 degrees. So I'll just draw this one further down here so there's space for it. I really need to draw an 80 degree angle, which is close to 90, but not quite. And that 80 degree angle looks the same as the 800 degree angle. The 800 degree angle spirals once, spirals twice, and goes 80 degrees extra. All right, last type of problems for this, without even drawing, of course, you can find coterminal angles. Find the measure of two angles that are coterminal with the given angle. So remember, any time you take a lap around the circle, you end up with a coterminal angle. So to do this, you either add or subtract 360 two times. You can do one add, one subtract. You can add twice. You can subtract twice. There's lots of right answers to these problems, and you would get your answers. So for 56 degrees, if I add 360, I'll get one answer. So 416 degrees. Or maybe I could subtract 360. So I would be at negative 304 degrees. These two angles would be coterminal with the original 56. That's one example of how it can be done. Or maybe I want to add. Maybe I want to add 360 because it's already negative. So 218. And maybe I would just like to add 360 again. Nobody says I have to do two different things. So 578. My two coterminal angles would be 218 and 578 degrees. They look like the original 142 degree angle, negative 142 degree angle, because they end in the same place. Okay? If you have questions, please ask in class.